Hello everybody. Today we are going to show you an experiment in which we can find the frictional force and the property of frictional force. The first question is, what are the objects needed to show this experiment? First of all, we have a spring balance. Here see, this is our spring balance. It is given in Newton and grams. Right, here you see, this is given in Newton and grams. You find clearly, if you want to study the least count of this spring balance, you see, between 0 and 1, there are 5 divisions, right? 5 divisions equal to 1 Newton. First of all, you find the least count of this spring balance. Least count, what is the least count? Least count is the measurement of one smallest division, right? That is the least count. Here, that means 5 divisions is 1 Newton. Let us find the least count of this spring balance. Can you see? Here we are finding that 5 divisions. You see, writing here 5 divisions. 5 division. 5 divisions is equal to 1 Newton. Therefore, 1 division is equal to 1 by 5 Newton. If we divide 1 by 5, then we are getting 1 divided by 5. 0.05 to the 10, 0.2 Newton, 0.2 Newton. That is the least count. That is the least count. That means in this spring balance, the least count is 0.2 Newton. Here you see, the least count is 0.2 Newton. I will find the frictional force. The first question is, what is frictional force? Frictional force, the force opposite to the motion. It is the force between the two surfaces. Here you see, if you see the frictional force, we will find the frictional force between this surface table and this wooden plank, right? The frictional force you will find between these two wooden plank and this table. You have to find this frictional force. Now we will find this frictional force with the help of this spring balance. Let us find out what is the frictional force in this case. If we move this, let us find what is the frictional force, or we can find the property of frictional force. Now we are moving this wooden plank. Here you can see in the spring balance that frictional force is very less or nearly 0.2. You see, 0.2 Newton in this case. 0.2 Newton. That is in the case of this wooden plank. Number 1, frictional force. Force. In case 1, wooden plank. In table and wooden plank, the real force is nearly 0.2 Newton. 0.2 Newton. And if you find that the frictional force is always opposite to the motion. You see, the frictional force is nearly 0.2. If you increase the weight, let us find. You see, this is a weight box. In the weight box, you will find the weights of different measures. That is, you see here, this is 100 gram. See, this is 100. This is 50 gram. This one is 50 gram. This is 20 gram. This is also 20 gram. This one is 20 gram. This one is 10 gram, 5 gram, 2 gram, 2 gram, and ultimately 1 gram. You see, this is 1 gram. Now we'll find the frictional force for different weights. Let us find if we increase the weight on the wooden plank. Suppose this is 50 gram. I am putting this 50 gram on the wooden plank, and let's see what happens in this case. Now if you move this spring balance and read the spring balance, what you will find. You see, here we are finding that the number of division is 2, right? Here you see, let's move this again. We are finding that here the reading is 2 smallest divisions means 0.4 Newton. In case of number 2, if we increase the weight, that is wooden plank plus 50 gram, wooden plank plus 50 gram, the friction force rises to 0.4 Newton. The reading is increasing. That means here the friction force increases, right? If we again increase the weight to 100 gram, what will happen? Let us find. Here we put the 100 gram weight on the wooden plank, and let's see what is the reading on the spring balance. Here we will see the reading of the scale on the spring balance. Here we are getting 4 smallest division. That is 4 into 2, 0.8. Therefore, we are getting, in this case, wooden plank plus 100 gram, the friction force increases to 0.8 Newton. In this way, what we conclude that whenever we increase the weight on the wooden plank, the friction force increases. That is, friction force increases, right? Let us again give more weight, that is 100 plus 50 gram. Let's see what happens in the next step. Let us find the reading again. In this case, nearly we are getting 1 Newton. Now case 4, wooden plank plus 150 gram plus 150 gram, the reading goes to 1 Newton. In this way, you can say that whenever we are increasing the weight on these wooden plank, the friction force increases, right? Let us take another. Let us increase the weight again. That is, we are giving 20 gram plus 20 gram, 40 gram, right? There is 100 plus 50, 150 plus 60, 70, 80, 90 and plus 10 gram. That is we are giving 200 gram, right? 100, 50, 60, 70, 80, 90, 100. That is 200 gram, right? If we give 200 gram on the wooden plank, let us find what is the frictional force, right? Let us pull this. Let us find the frictional force. Here we find that the frictional force increases and wooden plank plus 200 gram, that is wooden plank plus 200 gram, we are nearly getting 1.2 Newton, right? Now you see what we conclude from this experiment. We conclude that whenever the weight is increasing on the wooden plank, the frictional force increases, right? Here we find from this conclusion that our division is 5 division means 1 Newton. The 1 division is 1 by 5 Newton, which counter is 0.2 Newton. Therefore, frictional force in case of wooden plank is 0.2 Newton. Wooden plank plus 50 gram, we are getting 0.4 Newton. Wooden plank plus 100 gram, we are getting 0.8 Newton. Wooden plank plus 150 gram, we are getting 1 Newton. And wooden plank plus 200 gram, we are getting 1.2 Newton. In this way, you can find that the frictional force increases whenever we increase the weight on the wooden plank, right? Then the frictional force depends on the weight we placed on the wooden plank. In this way, we can find the frictional force of different surfaces between two surfaces, and you find that the frictional force is always opposite to the motion of the object. Suppose the object is moving in this direction. The object is moving in this direction. Suppose the frictional force will be opposite. That means the frictional force will be in this direction, opposite to the motion of the object. In this way, we can find the frictional force, right? Therefore, we are getting the result that whenever we increase the weight on the wooden plank, the frictional force increases, right? In the first case, whenever we take only the wooden plank, it is 0.2 Newton. When we put 50 gram on the wooden plank, it is 0.4 Newton. When we put 100 gram, the wooden frictional force is 0.8 Newton. When we put 150 gram, it is 1 Newton. And wooden plank plus 200 gram, we are getting 1.2 Newton. That means whenever we increase the weight on the wooden plank, the frictional force increases, right? In this way, frictional force is find out by the spring balance, right? In this way, you can find the frictional force between two surfaces, right? This wooden plank and this table. By increasing the weight, we can find that the frictional force increases whenever we increase the weights on the wooden plank. Dear friends, that means what we come to the conclusion. We come to the conclusion that whenever we increase the weight on the wooden plank, the frictional force increases, right? In this way, we can find the frictional force between two surfaces, right? We are finding the frictional force between this table and this wooden plank, right? But if we increase the weight, or if we increase the weight on the wooden plank, the frictional force increases, right? In this way, you can find the frictional force between two surfaces. Dear friend, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.